Hello, welcome back to another episode of Math with Hoss. You're watching Precalculus Season 2, Episode 30. We're continuing our investigation in trigonometry, and now we're going to look at some examples using the addition, subtraction, identities, which we've just derived, and we're going to use them to find some exact values of angles. So, if we have, for example, sine of 75 degrees, what we want to do is think about how to represent that 75 in terms of either a subtraction of two angles or the addition of two angles. And then we can use our identity to rewrite it and get an exact value. So in particular, we want to think about writing it in terms of angles that we already know the values of on the unit circle. So here's our unit circle here. When I look at this 75, because it ends in a 5 here, that tells me I probably want to use the 45-degree angle, which we know is over here, right? The reason why I'm thinking of 45 is because if you have a 45 plus some other angle that doesn't end in 5, that will give us the last digit of a 5. So then the question is, do we want to think of addition or subtraction? Okay. So, in other words, I could think of it this way. What minus 45 gives you 75? Or I could think what plus 45 gives you 75. Let's see what that does. So if we were to take 75 plus 45, that tells you that x is 120. In this case, for the bottom, x equals 30. So there's really no right or wrong way of thinking about it. In this case, you could use, so we could think of sine of 75 degrees as sine of 120 degrees minus 45 degrees. Or you could think of it as sine of 30 degrees plus 45 degrees. So notice we have actually two ways of thinking about this, and you probably figure out more combinations than just that. I just picked 45. You could have picked something like 135, for example, as angle, or 225. I mean, there's infinite possibilities you can choose. I just picked what was easiest. Though I will say you probably saw the 75 and just thought, oh yeah, well it's just 30 plus 45. But I just wanted to show like two ways you could have thought about it. So if I'm going to just work it out this bottom way here. So I'm going to just pick this route simply because the numbers are a little smaller and everything is in quadrant 1. But it doesn't really matter. So that means since sine of 75 is equal to the sine of 30 degrees plus 45 degrees, then this is the same thing as sine of 30 degrees cosine of 45 degrees plus cosine of 30 degrees, sine of 45 degrees. So we're using this identity. Sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Let's see, need a little bit more. Alright. Well, sine of 30 degrees is a half. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. And sine of 45 is root 2 over 2. So this gives you root 2 over 4 plus root 6 over 2. Alright. Oh wait, no, that's a 4. So root 2 plus root 6 over 4. There we go. That is our exact value for sine of 75. Alright, let's pick another example. Let's do a cosine one. So suppose we have cosine of pi over 12. Alright, so cosine pi over 12 is a rather small angle, right? It's smaller than pi over 6. And we know pi over 6 is actually 30 degrees, right? So pi over 6, this is 30 degrees. Pi over 12 is half of that. So that means pi over 12, it has to be 15 degrees. And we can verify that, right? We just remember if you take pi divided by 12, you can convert from radians to degrees by multiplying by 180 degrees divided by pi. And we get our 15 degrees. Cool. Alright, so we essentially are asking ourselves, what is cosine of 15 degrees? Same thing as cosine of pi over 12. Well, how you could think about it is, if you think about pi over 4, if you subtract a pi over 3, that's the same thing as pi over 12. So if you just think, well, 1/3 minus, or 1/4 minus 1/3, that will give you 1/12. So we could think of this as cosine of pi over 4 minus pi over 3. And from here, we can just now use our identity. So this has to be cosine pi over 4 cosine of pi over 3 plus sine of pi over 4 sine of pi over 3. So we're using the fact that cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. Alright. So cosine pi over 4 is square root 2 over 2. Cosine of pi over 3 is a half. Sine of pi over 4 is root 2 over 2. Sine of pi over 3 is root 3 over 2. And so notice we are going to get the exact same thing again. Root 2 plus root 6 over 4. Interesting. Alright. So we found our cosine and sine values for those two angles, and that's actually all I wanted to talk about, is just showing practically where you could use our addition subtraction identities, and that was for doing these types of computations. One example. Here soon we'll be looking at solving trig equations and trig proofs using these identities, but we're going to have to first derive some more trig identities before we really start diving into that, but it will be a lot of fun. Alright, well, thank you for watching this video. If you've been enjoying our content, please subscribe and consider supporting us on Patreon. Thank you for joining the math party, and I will see you next time.